All right, so this is part 2 of the lecture on moles and mole conversions. In the first part of the lecture, we talked about what the mole was, and we went over how to do a mass to mole conversion. So what I want to do in this lecture is show how to do the reverse, moles to mass, and then hopefully do the other two conversions, moles to particles and particles to moles. So what I'm going to do is I'm going to go ahead and erase what I had here from the last video, but leave the rest of the stuff up there. We had a conversion up here on how to go from mass to moles. And so now what we're going to do is we're going to kind of do the opposite thing. We're going to go from moles to mass. So let's say that I had, I don't know, 12.5 moles of, let's choose hydrogen. It'll give us a pretty good opportunity to talk about a couple things here. Notice when I wrote hydrogen, I wrote H2. It's because hydrogen is diatomic. And we've talked about that before. Make sure you know the diatomic 7, and that whenever you have those elements, they're always bonded in pairs. So I've got 12.5 moles of hydrogen, and I want to know how many grams of hydrogen that is. So this time, last time we went from mass to moles. This time we're going to go from moles to mass. We're going this way. But you'll notice we're still using the same conversion factor. To go from moles to mass, we're still using the molar mass. And where do you find the molar mass? On the periodic table. So I'm going to go down to the periodic table. I've got to turn it on here. Periodic table, here it is, bam! And two decimal places is fine. So 1.01 is what we're going to use for hydrogen. So let me turn that back off, 1.01, but it's hydrogen, and hydrogen is H2. So it's not 1.01, it's 1.01 times 2. It's two 1.01s because there's two hydrogens. So the molar mass of hydrogen is 2, I'm going to learn eventually not to do that, 2.02 grams per mole. And that is the molar mass of hydrogen that we found in the periodic table, the molar mass. And this, what we were given, is the molar amount, and what we're being asked to find is the mass amount, the amount in grams. So let's go ahead and set this up using dimensional analysis now that we've got all the components together here. We'll put our fractions. What we know to start with goes up here, 12.5 moles of hydrogen. Since we have the unit moles up here, moles right there, that's the unit that we're measuring in, right? We want to put moles down here so that it cancels. So you always want to put the same unit in the bottom of the next fraction when you're doing dimensional analysis. And then we have to use molar mass. We already decided that. We have to use molar mass. Molar mass is grams per mole. So we want grams per mole. And the molar mass of hydrogen gas is 2.02 grams per mole. And that goes with the grams, 2.02 grams for every mole of hydrogen. So 2.02 grams per mole. And you can put a 1 down there if you want to. Awesome. Now, when you're doing dimensional analysis, if a number is on the bottom, you divide, and if a number is on the top, you multiply. Moles is going to cancel out for us in this case, which leaves us with grams as our unit, which is what we want. We want to find grams of hydrogen. And so we have to multiply 12.5 by 2.02. So bring up my calculator again. Let me clear out the last problem here. And 12.5 times 2.02. And we get 25 something, 25.25. 25 point. Now, I've got three significant figures here, three significant figures here, so I'm going to use 3 over here. So I'm just going to go with 25.2 since there's no number after the 5. So 25.2 grams of hydrogen. Again, really important to have the unit and the substance with our answer in chemistry so that we know what the heck we're talking about. There you go. So that's how you go back and forth between moles and grams. The key to going back and forth between moles and grams is knowing how to set up dimensional analysis, which you can go back and review that online lecture if you need to, and knowing what molar mass is and where to find it, the periodic table. So now let's look at this side of our little conversion over there. Let me go ahead and erase this. You can rewind the video if you want to watch that some more, but I'm going to get rid of it right now. And we're going to look at going from moles to particles and particles to moles. Nice. Okay. So we've got, let me just color code the number of particles over here. We'll make it orange. All right. So let's say that you've got, oh, let's see, 19.75, because I was born in 1975. So 19.75 moles of, let's say, carbon. Carbon's a good element to do this with. And we want to know how many carbon atoms that is. Well, atoms, oh wait, it doesn't directly match anything up here. But you should know enough by now in this course to know that atoms are particles. So this is actually asking for number of particles when it asks for carbon atoms. So we're going to use dimensional analysis again. Wait, what's this? 19.75 moles. Oh, moles. Okay, so we're going to go ahead and highlight that in blue. Okay. So how do we get back and forth between moles and number of particles? Well, to get back and forth between the two of those, we have to use the number of things in 1 mole. And that's the number we were looking at before up here. And when you're using it as a counting number, it's mole, but this number actually has a name. It's called Avogadro's number to honor a famous Italian chemist. So we're going to use 6.022 e to the 23 to go back and forth between these two things, right? So we need to give that a, oh man, I'm running out of colors here. We'll make that red, I guess. Because there are 6.022 e to the 23 things in 1 mole. Okay. So how does this look when we set this up? We've got our dimensional analysis fractions. We've got 19.75 moles of carbon. So remember, you always want to put on the unit on the bottom of the next fraction that you have on the top of the previous one. So we want moles. And up here, it looks like we want atoms. Extend that line a little bit. And to go from moles to particles to atoms, moles to atoms. Now, I know it says particles up here, but you should know, hey, an atom's a particle. So hopefully that's not throwing you for a loop. It says that to go from moles to atoms, we need this number. But how does that number work? That's the number of particles in 1 mole. So the particle here is atoms, so that number goes with particles. So the number goes with atoms. 6.022 e to the 23, and that's the number of particles, atoms in this case, in 1 mole. And since this is on the top, we're going to multiply. But let's just make sure we got everything straight here. We used our molar mass as a conversion factor here. We've got moles over here that we started with. And when we're done, we should end up with a number of particles. So let's see what happens. Moles cancels, and it looks like we're going to end up with atoms of carbon, so that's good. So I definitely am going to need a calculator for this one. So we've got 19.75 times, and you'll notice I'm using the scientific version of this, so 6.022, and on this calculator it's this EXP button. See that E, the 23, and then equals. And it's not in scientific notation up here, but I can fix that with this FE button. Bam! Nice. So We've got 4 significant figures here, 4 significant figures here, so we're going to use 4 significant figures in our answer. 1 point, and that's something else I'm going to have to learn to not do. 1.189, it looks like, is what my answer is. 1.189. 1.189. 1.189. Oops, there's more. There's definitely more. 1.189 e to the 25. Whew, that's a lot. So e to the 25, which is the same as 1.189 times 10 to the 25. So whichever way you're more comfortable with, you can go ahead and use. So it's 1.189 e to the 25 what? Atoms is our unit and carbon is our substance. So that's an example of how you would go from moles of something to number of particles of that thing. So now our last thing that we have to do here is do the reverse of that and go from particles to number of moles. So erase that. And here we go. My pencil back. Let's say I had 1.48 e to the 24 molecules sorry about that, molecules of water. And I want to know how many moles of water that is. So molecules are a type of particle. So you're given a number of particles, and it's asking you to find the number of moles. So let's set this up. It looks like we're going to need Avogadro's number, 6.022 e to the 23 here. So here are our fractions. 1.48 e to the 24. And then I'm kind of out of room, so I'm going to write the unit up here. Molecules of H2O. And then down here I have to have molecules of H2O. Oh, we don't want H2O. Molecules, and then same unit, right? And then on top we're going to have moles. All right. So that is Avogadro's number right here that we got to put in a fraction right there. So it's 6.022 e to the 23 particles per mole. So 6.022 e to the 23 is going to go on the bottom this time because molecules are our particle. 6.022 e to the 23 molecules in 1 mole. And since it's on the bottom, we're going to divide. So let me bring the calculator back. Clear it out here. All right, so, oops, smooth. All right, so we're going to take the calculator and we're going to enter in 1.48 e to the 24 divided by 6.022 e to the 23. And that comes out to, let's see, we got 3 significant figures there. We got 4, so we're going to use the smaller number 3. So 2.457, because that is larger than 5. We're going to round that 5 up to 2.46. So 2.46, and you notice it says e to the 0, so it's just 2.46. So 2.46 what? Moles, because molecules cancels, of water. And there you go. As always, if you have any questions about anything from this lecture, please ask in class, and thank you for watching.